Hello, dear students. How are you? Those who has recently joined, start doing question number 25. And everybody, please turn on your camera. Please turn on your camera. Harshit, Nabila, Galvin, and everyone. Please turn on your camera and start doing. Gianna, Galvin, Harshit. Start doing question number 25. Then I will ask you that. Harshit, you there? And Gianna, is I'm audible to you?
Yes, sir.
So please turn on your camera and start doing question number 25.
So, I'm on my phone, and the camera it's not that it doesn't work on my phone.
Camera is not working.
Yes, yes,
So
sir.
let's confirm to your parents, and then if they confirms you, then we will leave it. Okay, okay. So just a minute, we're just going to call the team. Then they will call your parents.
Yes, sir.
Hello, sir. Please call Gianna's home parents that whether they are allowing her to turn off their camera or not. Okay. Harshit, turn on your camera. Then question number 25. You are visible, but the light that is going behind you is making you black. You done, everyone? This question number 25. Yes or no? Am I still doing? She replied, having on my note. That's why I said that if your video is turned on, this means that we can see you. Yeah. Galvin, you're doing? Where is? Okay. When you're done, please let me know.
I'm done, sir.
Okay.
So should we write the question?
No. Only
Oh.
answer should be. Let's have the question here. Write the question, okay? Write the balanced chemical reaction. So it is sodium carbonate. Sodium carbonate formula is, tell me, what is the formula for the sodium carbonate? Nabila, what is the formula for the sodium carbonate?
NaCO.
NaCO. Yes, you Harshit, what is the formula for the sodium carbonate? Harshit, what is the formula for the sodium carbonate? Please unmute your mic, Harshit.
Sir, I'm audible.
Yes, you are audible. Tell me, what is the formula for sodium carbonate?
Sir, NaCaCO3.
NaCaCO3. Yes, you Gianna, what is the formula for the sodium carbonate? Gianna, you there? Gianna, is I'm audible?
Yes, sir. Yes, sir.
Tell me, what is the formula for sodium carbonate?
So Na2CO3.
Maha, what is the formula for sodium carbonate?
Na2CO3.
Yes, it is Na2CO3. Sodium has valency 1 and carbonate ion is CO3 ion. Okay. So this is 2. Now you cross multiply this one, you will get Na2CO3, sodium carbonate. Okay. When react with hydrochloric acid. So what's the formula for hydrochloric acid? HCl. Okay. It will gives you what? It will gives you sodium chloride NaCl plus sodium hydrogen carbonate. What's the formula for sodium hydrogen carbonate?
So we can't see what you're writing.
NaHCO3.
What is the formula for sodium hydrogen carbonate?
NaHCO3.
Yes, sodium has one valency and hydrogen carbonate has also one valency. So when they have one valency, they will mix together. So they will cancel out each other and will form sodium hydrogen carbonate. Okay.
So I can't see what you're writing.
It's not visible what I'm writing.
No,
Oh,
sir.
just a minute. Is it visible to you now?
Yes, sir.
Okay. Next, if I'm talking further, it is sodium. Next question. Sodium hydrogen carbonate on reaction with hydrochloric acid. So what is sodium hydrogen carbonate? NaSCO3.
Yes, sir.
When react with hydrochloric acid HCl, it will gives you what? Sodium chloride plus carbon dioxide plus water. Okay. Actually, this reaction is saying sodium hydrogen carbonate, but actually it forms calcium, carbon dioxide plus water also. But we are just writing the word equation according to the question, so we just let it be. Now, copper sulfate. What's the formula for copper sulfate? Yes, you Gianna, what's the formula for copper sulfate?
So 2Cu. CuSO4.
Yes, CuSO4, copper sulfate, because copper has valency 2 and sulfate ion also has valency 2. So when they are same, they will form CuSO4. They will cancel out each other. Copper sulfate when react with what? When react with potassium iodide. Potassium iodide. So what is the formula for potassium iodide?
Okay.
Yes, Galvin, you never concentrate. You always look somewhere here, like somewhere like this, somewhere like this. Never look on the screen. Why you used to do the like that, Uta? It's not good. Okay. Just try to concentrate on the screen. What is the formula for? Let's just tell me, Galvin, what is the formula for the potassium iodide?
Ki.
Ki. When it react, it will gives you copper iodide. This formula is given to you. Copper iodide plus plus what's the formula for potassium sulfate? What's the formula for potassium sulfate? Sumaya, please turn on your camera. Sumaya, please turn on your camera. What's the formula for potassium sulfate?
Sir, can I answer?
Yes, tell me.
Sir, K2SO4.
K2SO4. Very good. K2SO4 is good. Good. K2SO4 is the formula for this. Okay, so this is the. So let's move. In the previous class, what we were doing, we have done up to chemical properties of. No, we have not done chemical properties. We were just studying the acid, bases, and salts, na? And we have done up to. Tell me, Maha. We have done the acid, bases, and salts, na? We were doing.
Sir, we did redox reaction. We did, you explained oxidation and reduction.
Okay, let's start studying the acid, bases, and salts today. Okay, the fresh chapter, acid, bases, and salts. So, what are acids? What are acids? So let me explain you. There are different scientists in this chapter. What we are going to study, let me explain you first. Okay, in this chapter we're
Sir,
going to study the yes.
for me, I've done till all factory acid base indicators.
For me, we have done.
Till all factory acid base indicators.
Yes, we have done this. So you used to study in the another batch. You change your time.
No, sir. I didn't change.
Galvin, we have studied in acid, bases, and salts. We have started the introductions. I know that.
Yes, sir, I started the
Ma,
exam.
were you absent in the previous class?
No,
I'm
sir.
sure.
Thanks, sir.
Okay. Okay. Let me discuss in a brief that what are acids. Just what are acids? So acids are those substances that dissociate their H plus ion in aqueous. Acid are those substances. And Gianna, were you absent in the previous class? I think so. You were absent.
Yes, sir.
Those acids are those substances that dissociate. Yes. Tell me, Nabila, what are acids? They dissociate what?
H plus ions.
H plus ions. Dissociate H plus ions in what? In aqueous. In aqueous. And what are bases? In what are bases? Tell me. Nabila, tell me what are bases?
So when they are added to water, they produce OH
Negative
plus
ions.
ion.
OH negative. OH negative
Negative.
ion. No? Okay, so what are bases? Bases are those substances that dissociate OH negative ions in aqueous. In aqueous. Okay. So yeah, have you done this one already written in your copy or not? No. Nabila, you studied that one because in the C2 batch or C1 batch, I think I've started the chemical equation reaction. I don't know where it goes. Let it be. So acid are those substances that dissociate the H plus ions in aqueous, and bases are those substances that dissociate the OH negative ion in aqueous. Okay, and this definition was given by Arrhenius. Arrhenius was the one who gave this definition. Okay. Now the another concept comes by the Bronsted-Lowry concept. Have you noted this one? Note it fast again. Nabila, you do revise it again. Okay, let it be.
Okay.
Note it down again.
Done, sir.
Okay. Now, coming to the next point is acids. Now, Bronsted-Lowry concept. Bronsted-Lowry said that acid are those substances that that donate. He used the word donate H plus ions. And bases are those substances that accept the H plus ion. That accept the H plus ions. So he uses the word donate, acid, accept, base. He do not use OH negative ion in his one. He uses only OH negative ions. Okay. Do this one, please. Next. Done. Done this one.
So what's the spelling of Bronsted?
Bronsted. Writing properly. Bronsted-Lowry. Okay, now let's understood the acid base in the light of RMS and Bronsted-Lowry concept view. Okay, so when we are adding, let you understood here that, for example, if I'm having HCl, okay, you add it to water. So I'm just writing aqueous here. For him, I am writing aqueous. So according to him, it will dissociate the H plus ions and OH negative ion. So if any substance added to water, aqueous means in water. In water. Okay, and if it is dissociating the H plus ions, okay, we'll consider it as acids. Okay. Now, if I'm talking about the bases, like for example, NaOH in aqueous. In aqueous, it will gives you Na positive plus OH negative ion. Okay, so this is considered H positive and Cl minus, sorry. Cl minus. Cl minus. So it is an acid. Why? Because it is dissociating the H plus ions. H plus ions are produced here. It is a base. Why it is a base? Harshit, where have you gone? Harshit.
Sir, I'm here.
So please turn on the camera.
Yes, sir.
Okay. So this is a base because it is dissociating the OH negative ion. Okay. So if it is dissociating the H plus ions, that is an acid. And if it is dissociating the OH negative ion, that is a base. Okay. Now moving to the next part here is just importantly you need to understand. Okay. Noted? Noted?
Sir, please wait. Done, sir.
Now moving to the next part here is, for example, if you are having, instead of according to Bronsted-Lowry, according to Bronsted-Lowry. Bronsted-Lowry concept, for example, if you have HCl and you add it to water, so it will, you know that water is like this, water structure is like this. You are going to study in the high class, the water structure is the band structure, like V-shaped structure, okay? When you add the water, so acid will donate its H plus ion to the water and it form H3O positive ion. Means one H plus ions will get dissociated here and will be attached with this O. Okay, with this O. And here it will acquire a positive charge, and this is called hydronium ion. H3O positive it will become, and it is called hydronium ion. Hydronium ions plus Cl minus. Actually, individual existence of H plus ion is not possible. Individual existence of H plus ions is not possible. Existence of H plus ions is not possible. Is not possible. So it attached with the water molecule. It attached with the water molecule. And form hydronium ion. Hydronium. Okay, got it? So when acid is added to water, what steps are taking? The formation of hydronium ion is taking place. Formation of hydronium ion. And second, ionization is also occurring. Ionization is occurring, is happening, and dilution is also happening. Dilution. So when acid is added to water, this phenomena occurs. First, the hydronium ion is added, is formed. Any H3O positive ion is formed. That is called hydronium ion. Okay, hydronium ion is formed. Second, ionization take place, means dissociation of H plus ions and OH Cl minus ion. It gets separated. What is dissociation? Like H positive and Cl minus ion get separated. Okay, they get separated. Cl become separate, and hydronium ion, the H plus ions of acid, is getting attached with the water. So we'll simply say here that the hydronium ion is formed and Cl minus is formed. So that is called dissociation. We use the word ionization or dissociation with this for this one. Okay, got it. And third is dilution. Dilution of acid takes place. You done? Done?
Yes.
Okay.
Yes.
Next is now, if in this case, if you check, according to Bronsted-Lowry, acid is donating the HCl is donating the H plus ion. So it is an acid. It is an acid because it is donating the H plus ion, and water is accepting the H plus ion. That's why it will form H3O positive. So here water is acting as a base. Acting as a base. Okay. Got it? You understood? Here the water is acting as a base. Next.
So, excuse me, sir.
Yes.
Sir, can I leave the meeting? I have to go for a test actually.
For what kind of test?
Sir, it is physics and chemistry test.
Right now. You are just going to leave the class.
Yes, sir.
No, you are
I
not
can send
allowed.
you the message now.
No, you cannot allow. You are not allowed. You will give the test after the class is over. Okay. Next. Next, if I'm taking the ammonia, NH3, ammonia when added to water, it will gives you ammonium ion, NH4 positive ion, and plus OH negative ion. You check it that ammonia, if I write water, water also have H plus ion and OH negative ion. I'm writing water like this way. Okay. So it will accept the H plus ions from the ammonia, so from the water, and will form ammonium ion plus OH negative ion. So tell me which is acting as a base and acid in this time? Which is acting as a base? Yes, Sumaya, tell me. In this one, which is accepting the H plus ions? Tell me, Sumaya, which is accepting the H plus ion? You unmute your mic. It's not on. Okay, tell me which is accepting the ion. So it will be the NH3, ammonium ion. Okay, this will be the ammonium ion. NH3 is accepting the H plus ion. So it is a base. Because it is accepting the H plus ion, you check, it become NH4 positive. So it is accepting the H plus ions. Okay, so it is a base. It is a base. And here water is donating the H plus ions. You check the water is donating its H plus ion. So this is acting as an acid. Okay, so when ammonia gas, it is not having any OH negative ion, but it is characterized as base because when it's added to water, it becomes. So please note it down here the question that why do ammonia, just a minute. Write the question and please write the answer also. Why do ammonia? I'm just coming back in a minute. Okay, just coming back in a minute. Do it, please. Noted, everyone? Harshit, Sumaya? Noted this one? So let me explain you this one, right? Oh, my mic is not working.
Sir,
Yes.
what is after H plus ions before water?
For water, it is the H plus ions. It is not the water. It is the H plus ions of water. Achha, what is written here before water? Let me.
Yes, sir.
Ammonia, when added to water, it accepts the H plus ion. You see that ammonia is accepting the H plus ion from what? Water. And form ions, except the H plus ions from water. It is from water. From water, and thereby increase the concentration of OH negative ion. Why? Because you see that if the H plus ion is being accepted, then the OH negative ion will increase. Okay, why? Let me explain you. Why do ammonia behave like a base when added to water? Still, it do not have any H plus ions. So let me explain you. Let, for example, you know that H plus ions when added acid show their property. Sumaya, are you there? And Harshit?
Yes, sir.
Sumaya, you there? Why have you turned off your camera? Start doing. So when water, why water is neutral? Because water has H plus ions and OH negative ion in equal amount. If H plus ions and H plus ions show the acidic property and OH negative ions show the basic property. If the OH and H plus ions both are having same numbers, so it will be neutral. Okay. But let you have 5 molecules of water. Okay. So they will be having equal amount of H plus ions and OH negative ion. Okay. And you add some ammonia gas to it. Ammonia. So ammonia, when added to water, it will start accepting the H plus ions. So let it accept the H plus ion, let it accept the H plus ion. Now the H plus ion which is attached with ammonia molecule, it form ammonium ion. And it is not showing the acidic property now. It is not showing the acidic property. Acidic property is only shown by this one because it is not attached with the ammonia molecule. Okay, so we'll see that there is only one H plus ion and 5 OH negative ions. So the basic OH ion concentration will increase. OH ion concentration will increase because most of the H plus ions get attached with the ammonia. Now they are not showing in the form of any ammonium ion. When ammonia accept the H plus ion, it form ammonium ion. Now the H plus ion which is attached with ammonia, it is not showing the acidic property. It is not showing the acidic property. You understood? Only the acidic property is shown by the unreacted, unattached H plus ions, which is not attached with them. So we'll see that these are showing basic character. So more the OH negative ion and less is the H plus ion, so it will show the basic property. Okay, Harshit, you there?
Yes, sir.
I'm not able to see you. So have you noted this one? That ammonia when added to water accept the H plus ions from water and thereby increase the concentration of OH negative ion in the solution, and thus the solution become basic in nature because of the increase in H plus ions. Oh, sorry, OH negative ion concentration. You understood? Everyone understood?
So like H2 is another neutral
What do you
acid
say?
or base. Like H2 is neutral, right?
H2O neutral, yes. But
So is
according to
there
Bronsted,
something else?
according to acid base, according to Bronsted-Lowry definition, if someone is accepting the H plus ion, it is a base, and if the one which is donating here, it is considered to be an acid. So it is a definitions. It is
So like that, is there another neutral?
no, it is not from neutral. We will say that water will be less basic as comparison to that of ammonia base. Okay,
Okay,
but
so
we'll say that according to him, according to definition of it. Okay, water will be treated as acid here. Okay, so now you
okay.
understood. Now moving towards
Yes.
the strong acid and strong base. What are strong acids? Strong acids or mineral acids? Okay, those acids which when added to water, they dissociate their H plus ions completely, are called strong acids. Okay, for example, like you have HCl. You added 100 molecule of HCl, then all of them are going to give you H positive and Cl minus ion. Okay, H positive and Cl minus ion. H positive, Cl minus ion. H positive, Cl minus ion. H positive, Cl minus ion. So they all are dissociating their H plus ions. Okay, they all are dissociating their H plus ion. So that's why it will be considered as acids. Okay, it is a strong assets. And if you are adding some, suppose you have this one. This is CH3COH. Right, you take CH3COH. You take 50 molecules of CH3COH. Only some of them will dissociate. Only some of them will dissociate. Otherwise, all of them will remain as it is. Okay. So actually, one thing you have to note it down. So may I look at this, please? Okay. That suppose you have this CS3, you have this CS3, you have this CS3. They are not dissociating the H plus ion. They are not dissociating the H plus ion. They are remaining in its original form. So only the acidic property is shown by H plus ions. Those, there are how many molecules of acid? 1, 2, 3, 4, 5, 6, 7, 8. And out of 8, only 2 are showing the acidic property. Other are not showing the acidic property. They are the molecules of acid, but they are not showing the property of acid, because if the molecule dissociate the H plus ion, then only they are considered to be acid. They will show the property of acids. Got it? So you can consider this one like, for example, if you are having an army of 100 people and only 2 of them are having arms. Okay, others are not having arm. So it means that only the 2 soldiers are there. Other are not considered. Okay, but in strong acids, all of them are going to have arms. They completely dissociate. All of them are showing the acidic property. Everyone is dissociating the H plus ions, so everyone is showing the acidic property. So all molecules are showing the acidic property. So what is the definition for the strong acid and weak acids? The strong acids are those acids which dissociate their H plus ions completely in aqueous, and weak acids are those acids that dissociate, that partially dissociate their H plus ions in aqueous. Okay, and they are the name of some acids. So please write down the name of those acids also. Note the definition. Strong acids are those acids that dissociate their H plus ions completely. Harshit, are you doing something else? Harshit,
Yes, sir.
are you doing something else?
No, sir, I'm writing it.
So why have you turned off your camera?
Sir, actually, the net is slow here, so that is why I just got disconnected. Now I'm done.
Okay.
So why are they also called mineral acids?
Because they are not obtained from the natural substance. They are obtained from some chemicals.
Okay.
Strong acids are also called mineral acids. Weak acids are also called organic acids. Simply write down a definition of those weak acids and write their name. HCl is hydrochloric acid, H2SO4 is sulfuric acid.
Done, sir.
Okay. Now similarly, write for the bases also. What are a strong base and weak base? Strong base are those base. Strong base. Those bases. Those bases that dissociate. Dissociate OH negative ions completely. Example NaOH, KOH. Weak base. Those bases. Partially or incompletely. Actually show me the copy that in which you are writing, please. Show me the copy from the back camera. Just come, become means because of light, I'm not able to see anything because the light is coming on the backward on the camera. Just turn around and try to show me only the copy, please. With the help of back camera. With the help of back camera. Are you using a tab, a mobile, or the PC?
So mobile.
So turn on the back camera, please.
Yes.
And then show me the copy. Show me the copy of the previous things also that we have done. Are you in India right now?
Sir, I'm doing it. Just
Examples of weak bases: MgOH whole twice, magnesium hydroxide. It is also called milk of magnesia. Milk of magnesia. Magnesia. Second one is ammonium hydroxide. Ammonium. Ammonium hydroxide. Hydroxide. NH4OH. It is NH4OH. Okay, show me the previous page, Harshit.
sir, actually because of the net, I cannot do this. Like I'm saying you, it is सब बीच में डिस्कनेक्ट हो रहा है इस वजह से मैं लिख नहीं पाया था.
Actually, this is the main reason for the students that every student should note their copy and you have to submit. Okay, because if you are not maintaining your notes, this will we are just putting effort on you to teach. Okay, and we are far away from you. But the thing is very importantly that these online classes are much better than the offline classes. because you can do productively better things at your home, sitting comfortably, okay? And you can go anywhere wirelessly because it means you are not bonded to go to the particular place every day. Okay, you can do, you are just free to fly everywhere. Just need a tab. You can do the class from anywhere. The classes are only effective if you are just maintaining your notes, if you are doing the homework, if you are doing the assignments, then it will help you. If you think the teacher is not here, we are not going to see you. Okay. Every student should show me. Okay. We'll talk the team. We'll make something mandatory for the student that they must submit their copy. Okay.
Yes.
While they are, we'll just try. We'll just go and think about this one also. But the students are not hiding themselves behind the camera. They are just not doing their work properly. So what? How our efforts are going into a pit. Those students, the way the Learnivio is teaching something, how it is different. No one in the online classes are having a batch of minimum 80 students. You can go anywhere. They are just having 50, 100 students in the class. And they are not concentrating on the students. They are not saying that Harshit placed on a camera. Then they will never say. Okay, they will not say, show me the assignments. We are just working for every students. Okay, why we are just working for it? Because you are just paying us and we are just working hard over it. And if you are not maintaining your notes, it will indirectly bother us, because when you do well, we will have you the result. We'll promote our website. We will do everything. Okay, not only your marks is benefiting you, it is also benefiting us.
Yes.
Okay, and how it will affect? If you like the class, if you're not maintaining the notes, it will affect. Okay, so it is magnesium hydroxides when react with ammonium hydroxide. Magnesium hydroxide, ammonium hydroxide are the weak base. The next one is calcium chloride. It is important for the calcium chloride. Just calcium hydroxide. Calcium hydroxide is weak base, but not so weak, but not so strong. We'll discuss it later, that how it is weak. Calcium hydroxide. Okay, it is not so strong, not so weak. And another, except this two, these are the two strong base. Otherwise all are weak. Otherwise all are weak. Okay, got it? Now just concentrate here. Just concentrate here. If you have magnesium ion, it means this ions you have received from magnesium ion. If you it means this you have received from magnesium hydroxide. Okay. If you have calcium ion, it means that you have received it from calcium hydroxide. If you have sodium ion, it means that you have received this ion from sodium hydroxide. Sodium ion is received from sodium hydroxide. If you have potassium ion, it means that you have received it from potassium hydroxide. Okay, got it? So magnesium ion received from, if you have ammonium ion, so it means that you have received it from ammonium hydroxide. Okay, like this way. Got it? So moving here, one thing is that the ions from where you are taking, okay, you need to memorize that magnesium ion. If there magnesium ion, it means it has come from magnesium hydroxide. If you have calcium ion, it means it has come from calcium hydroxides. If you have potassium ion, it means it has come from potassium hydroxide. Similarly, if you have sulfate ion come from H2SO4, sulfuric acid. Okay, this is sulfuric acid. If you have chloride ion come from HCl, hydrochloric acid. HCl, hydrochloric acid. If you have nitrate ion, NO3, so it means this nitrate ion come from HNO3, nitric acid. And these are strong acids. These are all strong acids. Okay, yes, these are all strong acids. Got it? The next one is if you have received the ethanoic ion CH3COO minus, so it means it has come from ethanoic acid. Ethanoic acid. Right? Acid. If you have phosphate ion PO4 minus, it means it has come from phosphoric acid. Phosphoric acid. Phosphoric acid. Got it? Okay, if you have carbonate ion CO3 minus 2, it means it has come from carbonic acid. H2CO3, carbonic acid. Note it down, please. Carbonic acid. And these all are weak acids. These are all weak acids.
Sir, can I leave now?
Just a minute. Why there is a need? Why there is a hurry?
Sir, I just said you that there is a test. And
Let it be, na? Let it be. Let it be. Said that you were in the class, I was explaining you. That's why I'm not able to be. Okay. So just a minute. Just listen to me.